Okay, what are fractions? Fractions have a numerator, up, and a down denominator. So the denominator is down on the bottom, and a fraction is made up of these two things. So what are they? The bottom number, denominator, tells you how many parts there are in total. So if we look at our pizza pie down here, this entire pizza pie has a certain number of total wedges, just like a Domino's pie, maybe Pizza Hut as well. You get 8 pieces in total. And then the numerator on the top tells you how many of those divided parts you've selected. And you can see here a number of those pieces of pie have been selected, or in my house, eaten. There's two kinds of fractions. A proper fraction, also called a common fraction, is less than a whole. Therefore, the numerator must be smaller than the denominator. So this is an example of a proper fraction. Another example of a proper fraction is 1/2. Anything that has a smaller number on the top, 7/9. That's a proper fraction. An improper fraction is greater than a whole, or more than one. Therefore, ergo, the numerator must be larger than the denominator. So an improper fraction is top-heavy. We might use that 7 again, but we'll put it over 4. See how there's more than one whole there. 4/4 would make a whole, and we have an extra 3 there. Or we could have, let's see, even 6/5. That's just enough to be greater than a whole. Whole numbers can also be represented as fractions. So a couple examples are, if I wanted to represent the number 1, if I had a total of 4 parts and I used all 4 of them, 4/4 is 1. And if I use the example 8/4, I can reduce that down to, let's see, how many 4s? There's 2 sets of 4, to 2, or 2/1. So that's any whole number can be written out as a fraction. The number 13 is a fraction when I put it 13/1. Or another example is 275 million, no, just 275/1. So there's my fraction, my whole number represented as a fraction. Any whole number over 1. So now let's have a look at this. So we got a pizza, I'm going to call it a pizza. It's a pizza pie. So how many pizzas in total is the pizza divided? 1, 2, 4, 5, 6, 7, 8 pieces, all right? How many pieces have been selected or shaded? 1, 2, 4, no, 3. That's 3. 3 pieces. Okay. In representing the shaded fractions of the pizza, what must the denominator equal? So the denominator is the toto, all of them possible. The denominator must equal 8 because that's the total number of pieces we could possibly choose from. And the numerator is going to be equal to the ones that we have chosen. You'll remember that from up above. Denominator is how many parts the whole is divided into, 8. And the numerator tells us how many of the divided parts we selected. So write the amount of pizza selected as a fraction. We selected 3 out of the possible 8. Now represent the fractions 3/5 and 9/5 on the number line. Now a number line doesn't always have to have whole numbers on it. So if I choose any point in the world, I mean, I could make that 0, and I could make that, let's see, 1, 2, 3, 4, 5. I can make that 1. I wonder why I counted 5. So this is, let's see, another way to look at that. That is 0/5. This is 1/5. 2/5. 3/5. 4/5. And 1, as I told you up above, is actually 5/5. So if we look at this way, this is actually from 0 to 1 whole. Perhaps I'll put it up there, and then 1, 2, 3, 4, 5. That would be 2 here. So that's 5/5. What we're asked for is 3/5. So I can get rid of those little puppies. Yeah, I might leave 5/5 there just to remind me. 6, 7, 8, 9/5 is very close to 2. So that's how I put those on a number line. I actually can divide my number line up into those sections because I know I'm going to have 5 sections because my total possible out of the whole is 5. So represent the fraction 3/4, 3/4, in 3 different ways using a square divided into 4 equal regions. Well, our square is given to us. It'd be nice to use a ruler, but I'm first divide that into, that's my total possible regions. I'll do that with all of the squares. So each of these is divided into 4 parts. So I could choose these 3. I could choose these 3. who's the odd man out? I could choose these 3. So all of these represent 3 out of 4. A little floppy there, a little sloppy. Leaving a different one unselected, but that's how we could show that on our square. Now, in your exercise book or online, you're going to go and you're going to find exercise 1, and if there's an A and a B and a C and a D component to do that, you're going to do all of them. For exercise 3, you don't have to do exercise 2. If you do, that's great, but you don't have to. For exercise 3, you do D only, and in this example, you're given a shape, and you're given A and B and C and D and a whole bunch of questions. You just need to do the questions that relate to that D shape, and so on and so forth. You notice these little stars. These stars in no way mean optional. They mean that the questions are getting a little bit harder. So they are the ones you might choose to work on in class when the teacher's there to help you, or those are the ones that you may choose to skip only if, and this is a big only if you've been away, you've fallen behind for some reason, and then we just absolutely have to finish this, and then we get as far as we can with these before we have to move on to the next thing.